Here we have a triangular thin plate of steel that weighs 50 pounds per square foot. The right edge of this triangular plate is given by the line x plus y equals 4. We are to compute the total moment about the y-axis. So we need to compute, so we want to find my. This is what we're looking for. All right, so to do that, let's first look at, so d my is plus or minus for the orientation, the distance from the axis, times the weight dA. Times the weight times dA. All right, so we got to draw a rectangle, a thin, small rectangle. And the way to remember this is, notice that we're rotating about the y-axis. If we're rotating about the y-axis, then our small rectangle is going to be vertical. So the way you can think of that is, if you're rotating about the y-axis, then you want a rectangle that's parallel to that axis. If we were rotating around the x-axis, then we want a horizontal rectangle, a rectangle that is parallel to the x-axis. But since we're rotating here about the y-axis, we want a rectangle that is parallel to the y-axis. That's what I've drawn here. Okay, so d my. Now think about orientation here. Now think about if this thin plate of steel was actually just a thin piece of plastic or wood, and this was our steel rod, like we put on the platform in examples 1 and 2. And now think about what happened if you, thinking of this y-axis as the only place that can rotate, if you were to put a steel bar like this onto this thin piece of plastic that can rotate clockwise or counterclockwise around the y-axis, this thing would rotate into the page. And from this arrow here, we can see that rotating into the page is positive. So we have positive. Now we want to have distance from the axis. So our distance from the axis, this is an x value. Right, so this will be x the weight is 50 pounds per square foot, and now dA. So now we want to get the area of this thin rectangle here. All right, so remember that dx is going to be the width here, so we'll have a dx. And we just need the height. Now remember this line here, this line right here, right? The entire thing there, that's x plus y equals 4. So solving for y, we get 4 minus x, 4 minus x. And now my is going to be our integral from 0 to 4 of this thing, of d my, which we see from above that is 50x 4 minus x dx. doing the math there, we get 533.3 foot-pounds. And that's our moment. So when we do moment about the y-axis, we're going to have everything in terms of x, like we have here. And you'll see when we do a moment about the x-axis, everything will be in terms of y.